Okay, so now that we know something about the biological and geological history of the Earth, the question is what kind of a planet and what kind of a solar system are we going to be looking for so that it has the same kind of life or has the capability of having the same kind of life as the Earth does. So, first criteria is how many stars are going to be in the solar system. So, our solar system only has one star, the Sun. So, similarly, we're going to be looking for solar systems in our galaxy that only have one star. Because if it has more than one star, let's say it's a binary star system, each of the two stars is going to be having a certain amount of gravity acting on the planets that are in orbit around those two stars. And so that might mean that the orbit might change as it goes around the two stars. If the orbit changes, that means the climate could change. If the climate changes, then that could affect what kinds of life could live on that planet. All right, the next thing is what about the size of the star? Okay, our star is a yellow-white star. We do not want to be looking for a star that is a big blue star. So the big blue ones are the hot ones, and that means that they are going to run through their fuel very quickly. So they have a very short lifespan. And the problem with that is that Earth is about 4.5 billion years old, but it took like 4 billion years to go from bacteria to worms. And then for the past 500 million years is where we go from worms all the way up to us. Okay, if you are in orbit around a big blue star, those things evolve so quickly that chances of any advanced life being on those planets in orbit around those stars is very slim. Now you could, however, use an orange star because an orange star is going to evolve slower than what the yellow one is. The problem is the orange star doesn't give off as much energy. So that would mean that your planet would have to be closer to the star if you wanted to use an orange-sized star. Okay, next is going to be your distance. So the planet needs to be the right distance from the star. So if it's too close to the star, it's going to be too hot. And then you could end up with a Venus. If you're too far away, you could end up with like a Mars, where it's too cold. So you don't want it to be so hot that the oceans boil away, and you don't want it to be so cold that the oceans freeze. So you have to be just the right distance away from your star. What about the size of the planet that is in orbit around this star? So we don't want it to be too big and we don't want it to be too small. So if the planet is too small, then it's going to cool off rapidly, which means it might lose its plate tectonics, which means it might lose its ability to produce an atmosphere. If it's too small, it's not going to have much gravity, so it won't be able to hold on to an atmosphere. If the planet is too big, then it might have too much gravity, and then you wouldn't be able to walk around on its surface. And then also, it might have too dense of an atmosphere, so the pressures would be too high. Okay, another thing is we're looking for a planet that has a relatively large moon in orbit around it, because that moon acts like a stabilizer. So that if you've got a tightrope walker, they don't hold their arms like this because it's easy to tip over. So they take their arms and they hold them out like this. So if you've got weight out here, it acts like a stabilizer. So if you have a planet that has a moon in orbit around it, that's going to keep the planet from tipping over. And so as millions of years go by, a planet that doesn't have a moon could be spinning like this for millions of years. But then in another million years, it will be spinning like this, and then it could be spinning like this. So its tilt could be constantly changing. Because the Earth has a big moon, we're tilted at 23 degrees, but it only varies by about 5 degrees. So that keeps our climate stable, which is what we're going to need if we're going to have life develop on this planet. Okay, then the presence of a large gas giant, such as Jupiter. So Jupiter's gravity acts like a giant vacuum cleaner, and so it helps to keep debris from striking Earth. So we're on the lookout for also a solar system that is going to have a large gas giant. Okay, then we need to have liquid water oceans. So it can't be so dry that they evaporate, and it can't be so cold that they freeze over. Okay, also we're looking for an oxygen atmosphere. So that means you can't have an atmosphere like Mars, where it's made of carbon dioxide, and you can't have an atmosphere like on Titan, where it is made of methane. So it has to be an atmosphere composed of oxygen. All right, let's take a break, and when we come back, we will talk about possibilities of life in our own solar system.